2 rockets, 2 coasts, and just over half an hour between launches. That's the cadence SpaceX hit in the last day, setting a new record for back-to-back orbital missions. We'll get into what that means for the future of spaceflight in a moment. Welcome to the Automated Daily Space News Edition, the podcast created by generative AI. I'm Trent Teller, and today is August 16th, 2026. Over the next few minutes, we'll walk through the most interesting space stories from roughly the last 24 hours, from record-setting launches to military space technology to the sun sending a blast our way, plus what you can see in the sky tonight. As always, the goal is simple: clear, calm, and curious coverage of what happened and why it matters. This episode is brought to you by Stock MVP. Stock MVP helps you invest like the pros using data-driven insights. Find the link in the episode notes. Let's start with that headline-grabbing launch doubleheader from SpaceX. On Saturday night, the company flew 2 Falcon 9 rockets just 38.5 minutes apart, one lifting off from Cape Canaveral in Florida and the other from Vandenberg Space Force Base in California. The first mission carried 8 satellites for Globalstar, part of an effort to refresh their low Earth orbit communications constellation so it can keep supporting voice and data services worldwide. Shortly after that booster landed back at Landing Zone 40, another Falcon 9 launched from the West Coast carrying a classified payload for the U.S. Space Force on a mission designated USSF 366. On the technical side, the Florida booster was flying for the 14th time and still returned safely, while the California booster landed on the drone ship Of Course I Still Love You, marking the 650th successful Falcon booster recovery overall. But the bigger story here is cadence and reliability. When a company can turn around 2 orbital launches less than 40 minutes apart from different coasts, with both boosters coming home, it sends a clear signal about how routine reusable rocketry is becoming. For customers, that means more flexibility and shorter waits. For competitors, it raises the bar on what it means to be a high-throughput launch provider. There's also a strategic angle. The Globalstar flight reflects the ongoing build-out and maintenance of commercial satellite constellations, which underpin everything from emergency phones to asset tracking. The USSF 366 mission, meanwhile, shows how closely national security space now leans on commercial systems. Instead of a unique, expendable heavy rocket, the military is increasingly putting sensitive payloads on a workhorse commercial vehicle. Put together, this record-setting evening offers a snapshot of where orbital launch is going: faster, more flexible, and deeply intertwined with both commercial broadband and defense.
Sticking with the national security side of space, there's another story in the last day that speaks to how militaries are thinking about satellites. Rocket Lab has been awarded a $397 million contract from the U.S. Space Force to build a new line of compact satellites, nicknamed Flatellites, designed to detect and track airborne threats from orbit. Details are still emerging, but the basic idea is to use a fleet of relatively small, standardized spacecraft rather than a handful of large, bespoke satellites. That makes the system more agile, easier to refresh, and harder to knock out. This is significant because it shows how defense agencies are embracing the same small-sat trends we've seen on the commercial side. Companies like Rocket Lab built their business launching and operating small satellites for Earth observation and communications. Now that approach is being folded into military sensing and warning architectures. If it works as planned, the Space Force could gain faster response times and the ability to update its hardware much more frequently than the traditional decade-long satellite cycles. There's a broader implication here for the space industry. A contract of this size, tied to cutting-edge sensing needs, helps validate the business case for small-sat manufacturing and operations beyond pure commercial markets. It also creates a feedback loop. Defense needs push companies toward new designs and capabilities, and those capabilities can later spill back into civilian and scientific missions. So even if this particular program is focused on tracking airborne threats, the technology it supports may eventually influence how we build future Earth-observing or climate monitoring satellites.
Now let's turn from rockets to the star that powers them, the sun. Because space weather over the last day has been quietly setting up an interesting start to the week. Observers report that on August 14th, a long filament of solar material erupted from the sun and launched a coronal mass ejection, or CME, toward Earth. According to space weather updates, that wave of solar plasma and embedded magnetic fields is expected to arrive around August 17th, with minor geomagnetic storms on the order of G1 level possible. In the meantime, the last 24 hours have seen unsettled to active geomagnetic conditions, driven mainly by fast solar winds streaming from a coronal hole, combined with a co-rotating interaction region where different flows of solar wind collide. For most people, minor geomagnetic storms sounds abstract, but the impacts are very real, even if they are usually subtle. On the positive side, G1 level activity can enhance auroral displays at high latitudes, meaning skywatchers in northern regions may see brighter, more dynamic northern lights if local weather cooperates. On the risk side, space weather at this level can cause small voltage fluctuations in power grids, add noise to radio communications, and increase the background radiation environment that satellites and astronauts experience, though they are designed to withstand these conditions. What makes this particular event interesting is the sequence. First, a period of fast solar wind and interaction-driven activity, then the arrival of a distinct CME. That pattern is useful for scientists who model how different types of solar outbursts propagate through space and couple to Earth's magnetic field. We are still early in the ramp-up towards solar maximum, so each well-observed CME adds another data point for understanding how the more intense storms we might see in the next few years could behave. In short, it's a relatively mild space weather event, but it's a reminder that the sun is not a static backdrop. It's an active system whose moods matter for technology-dependent societies.
If you prefer looking up at planets rather than auroras, the last day has offered some nice alignments for early risers and evening skywatchers. On August 15th, Mercury and Jupiter appeared in a close conjunction in the constellation Cancer, with Mercury passing just north of Jupiter in the pre-dawn sky. The pair rose roughly an hour before the sun, creating a compact grouping low on the eastern horizon. Nearby lies the Beehive Cluster, or M44, a sprinkling of faint stars that observers at higher altitudes can spot with binoculars when skies are dark and clear. Later in the day, Venus reached greatest eastern elongation, standing about 46 degrees away from the sun in our sky. Practically, that means Venus is now particularly well placed as a bright evening star, hanging in the western sky after sunset. Around this date, sky guides point out that you can look for Venus just to the upper left of the waxing crescent moon, the two of them sinking slowly as the twilight deepens. From a backyard perspective, it's an easy way to spot a planet. Find the thin crescent moon, then look a little to the side for an unmistakably bright point of light. These arrangements matter for more than just pretty pictures. Planetary conjunctions and elongations are some of the most accessible celestial events for people who do not own telescopes. They're simple to explain. Two worlds passing close together from our vantage point, or a planet reaching a geometry that keeps it in the sky longer, and they happen often enough to serve as reliable entry points into observational astronomy. For educators and communicators, weeks like this offer a chance to invite people outside, show them a handful of bright objects, and talk about orbital motion in an intuitive way. And for anyone listening right now, if your western horizon is clear after sunset, Venus is currently about as easy to see as it ever gets.
While we're on the subject of sky watching, let's connect that planetary show to something more dramatic: meteors and eclipses. NASA's astronomy picture of the day for August 15th features a striking image of bright Perseid meteors streaking across the sky over Sweden. The Perseid meteor shower, fueled by debris from comet Swift-Tuttle, peaks in mid-August each year and is known for fast, bright shooting stars that can be seen even from moderately light-polluted locations. This particular image captures multiple meteor trails in one frame, illustrating just how active the shower can be under dark skies. The description also notes that for many skywatchers, this night of meteors followed closely on the heels of a much-anticipated total solar eclipse on August 12th, which swept across parts of Europe in the evening. In other words, some observers enjoyed an eclipse, then shortly after got a strong Perseid display, a rare combination of two major celestial events within the same week. The APOD mention highlights that sequence and points readers towards a growing gallery of eclipse images, documenting how the moon briefly covered the sun and cast a narrow path of daytime darkness. The news here isn't that the Perseids or eclipses are unexpected. Both were predicted long in advance, and both unfolded roughly as forecast. What's interesting from a communication standpoint is how these events can stack. Having a widely covered total solar eclipse followed by a popular meteor shower helps sustain public attention on the sky. People who went outside for the eclipse may be more likely to read about or watch for meteors, and images like the APOD photo act as a bridge between those experiences. That kind of momentum is valuable for astronomy outreach. It keeps the sense of wonder alive and makes it easier to talk about more complex topics like orbital mechanics, cometary debris, or the interplay between the moon's shadow and Earth's atmosphere.
To round out today's space stories, let's leave Earth's skies behind and take a quick visual trip to Mars. A recently highlighted 4K video compilation brings together footage from NASA's Perseverance and Curiosity rovers, offering a high-resolution tour of the Martian surface. The video showcases everything from dusty plains and layered rock outcrops to the rover hardware itself, stitched together from still images and panoramas that the missions have been sending back over the years. It is not a new scientific result so much as a new way to experience the data visually. What makes this noteworthy in a daily roundup is the reminder of just how long-lived and productive these rover missions have been. Curiosity has been exploring Gale craters since 2012, investigating ancient lakebed sediments and climate history, while Perseverance has been roaming Jezero crater, studying a former river delta and collecting samples for possible future return to Earth. Over time, their cameras have produced a massive archive of images, and when those images are reprocessed and presented at modern video resolutions, the result feels less like a distant probe and more like a slow, methodical road trip through another world. From a public engagement perspective, high-quality visual compilations like this help bridge the gap between raw mission data and everyday viewers. Not everyone wants to read a paper about sedimentary structures or regolith grain sizes, but many people will spend a few minutes watching an ultra-sharp panorama glide across their screen. And that matters because support for complex missions, including eventual sample return, depends in part on people feeling connected to what the spacecraft are doing. So while the video itself is essentially a repackaging of existing imagery, it's newsworthy in the sense that it repurposes that imagery into something that can reach a broader audience and keep Mars exploration present in the public imagination. Thanks to our sponsor, Prezi. Prezi helps you create stunning AI-powered presentations in minutes. Find the link in the episode notes. That's it for today's run through the latest from orbit, the sun, and the night sky. We saw how a single evening of launches can illustrate the future of high-cadence reusable rockets, how defense agencies are leaning into small satellites, and how a relatively modest solar outburst still matters for our technology and for aurora hunters. We also checked in on planets lining up at dawn, Venus shining in the evening, meteors and eclipses keeping eyes on the sky, and Mars exploration turning into immersive 4K experiences. If you enjoyed this space-focused edition of the Automated Daily, consider sharing it with someone who might like a calm, fact-based look at what's happening beyond Earth. I'm Trent Teller. Thanks for listening, and I'll talk to you next time.